I would like to introduce our next speaker, which is Kent Larson. He is the director of the City Science Initiative at the MIT Media Lab. So he's working on these issues that I have just mentioned that are very important, not only in Chile, in all the countries in Latin America. He's an architect, and his research focuses on developing urban interventions that enable more entrepreneurial, livable, high-performance cities. His curriculum is very long. He has many awards and books, and he has done many things. But to make the story short, I will like to have an applause for Mr. Kent Larson. And welcome. Thank you for coming here.
Thank you. So it's great to be here and see my new friends from Chile. And I hope we'll put together a great project with Chile. We're working on those ideas, and with any luck, later in the year, we'll have something together. I'm going to talk about the power of without. Okay, anybody have any idea what I mean by that? No? Okay, so we usually think of, particularly the whole smart cities movement, of adding things to cities, cities with more. And my frustration with this approach is it's already antiquated. It's about optimization and efficiency. It's making existing legacy systems a little bit better. And we can do a lot better than that. So we're thinking about cities without. And you can see some little teasers going by. So anybody have any ideas for what they would like to do without? And when I say without, I'm talking about replacing antiquated legacy systems with new systems. Traffic. Mobility without cars. I'll talk about that in a minute. What else? What?
Noise.
Noise? Okay, you got to frame that as a without. Cities without noise? Okay. Community? Yeah. Industry? Manufacturing without factories? That's a good one. Learning without schools. Healthcare without hospitals. One more. No? Politicians, yes, exactly, exactly. So we have one, governance without bureaucrats, that we've been working on. All right, so I'm going to talk about mobility without cars, okay? So this is the experience in most major cities. And I think in 20 years, we'll look back on this era and we'll wonder what our era was thinking about. And this is a good day. See green and yellow up there. On a bad day, that's red. And cities are just becoming totally constipated. You know, you can't move around in many of these cities. So we have this notion that we need to look backwards and forwards at the same time. Go back to when communities functioned well, when people lived near where they worked and they had amenities within walking distance, close social ties, and then add all the new technologies that will improve the lives of people. And in these compact neighborhoods, we think we need to have many different mobility modes. And these are the ones in red that we've worked on, but walking is the most important, designed for walking, and shared bikes, et cetera. And, but you see, we still have a car here. I've been showing this, I started showing this many years ago, and we had the city car. So we'll talk about the city car a little bit. This is a little bit about my legacy, the history of these issues. So we decided to design a car that was better for the city than conventional cars. And parking is one of the huge problems. So in this case, we had 4 innovation: robot wheels, drive motor, steering, braking, suspension, each wheel, drive-by-wire, number 2, folding. So the length of the car is the width of a conventional car. You get 3 to 1 in a parking space, and front egress. You step directly out on the curb, no side doors. And what in my group, at Media Lab in general, we like to build things. So we like to design things, we like to model their impact, and then build prototypes. So this is a prototype that we built. You see the yoke pivots left and right. We tested this in Spain, so you can, it goes vertical, you step directly out. Had all those 4 features I mentioned, robot wheels. And then when we finished that project, I said, you know, this is kind of a cool car. We got a lot of press, but let's not do cars anymore. The future of cities has to be getting rid of cars. So we decided that the future was bringing these three things together: autonomy, vehicle sharing, and electric drive, sensor network that facilitates it. We started thinking about autonomy. So if you have an autonomous vehicle in the city in one of these compact communities, like I talk about, the vehicle has to communicate its intentions. So that's what it's doing here, eyeballs that are headlights that track. And by the way, car companies are now doing this. We did this project about 8 years ago, I think it was. We looked at the roadmap for autonomous vehicles, and you can see the upper right, full autonomous driving in all traffic conditions. The industry, some in the industry are saying 8 years, some others are saying 20 years. I think it's somewhere in between. But you already have robots operating in logistical centers, and we said, let's focus on driving in bike lanes. The cost of autonomy computation was coming down precipitously. These are all MIT projects. 2007, it was $100,000. Now what we're doing is $600,000. We decided that what the city needed was something between these shared stationless bikes that one finds in cities. Do you have those in Chile yet? Yeah. Bike pollution, bikes everywhere, right? And then ride sharing like Uber, Lyft. Do you have those? You have Uber there. Okay, so you have both. This is something right in the middle. We call it a PEV. It's a persuasive electric vehicle. It persuades you to shift to a more sustainable mode, and it persuades you to get physical exercise. So how does it work? So you call for it like you would an Uber. This little lightweight autonomous vehicle comes to you wherever you are. You drive it to your destination. We don't care about autonomy being for moving people, unless you're disabled or elderly, then it's fine. It's constrained to a bike lane. And by the way, most trips in the city are short distance, low speed, one person. Certainly that's the case with my car. I average 12 miles an hour on my car in Boston, and I have consistently for years. So watch what happens here. So these two young women are oblivious in the bike lane. The vehicle approaches them, does a little swerve around them. One smiles, the other doesn't even look up from her phone. So this is a social robot, and there can be many different variations of this. We like to also test things in the world. So this is a living lab experiment in Taipei, where a lot of our funding for this project is from Taipei. They don't make cars, but they have a great bicycle industry, great electronics industry. And in this case, you see this fellow just pulled right in front of it just to mess with the vehicle. You don't know what people will do. That's why you have to test out in the field. And it was a lot of fun. So we learned a lot from this. And now we're building these modeling and simulation tools where we can model different scenarios. So what happens when you toggle the different vehicles allowed on different roadways? You move residential and commercial together farther apart. You can restrict certain vehicles and cars from different bike lanes. And we're building now these modeling tools where the roads are red because we've added too much density, but then we can toggle from private cars to shared lightweight autonomous vehicles like this. The roads go green. We can move as you move housing near the office, then you can add even more density because you're reducing traffic congestions. So these are the kind of things we're working on. Housing without rooms. I think two things we have to get rid of in the city. We have to get rid of bedrooms and get rid of parking spaces. So this is former Mayor Bloomberg standing in a 300 square foot micro apartment taped out on the floor saying, in order for New York City to remain financially and economically, culturally competitive, we have to provide affordable housing for young people. This was a terrible apartment. It was 300 square feet, about 19 square meters. And the bed dominated the place. You had to pull out the sofa bed, almost no storage. So we said, let's make it a third smaller, but 3 times bigger in terms of functionality. And so you start by developers building these simple bubbles of space. This 19 square meters, add a piece of furniture that integrates architecture, robotics. This is I'll make connections to manufacturing. This is a new way of building because that you offload most of the complexity of in this case, the home, to the controlled environment of the factory where there's no limit to the sophisticated technology that one can integrate into a prefabricated piece of architectural robotics, effectively what this is. So in this case, auto-magically, the bed appears, it's a queen-size bed, dining room for 6, living room for 6, very small bathroom, but it opens up to be handicap accessible, gives you access to a shower and a washer dryer, things like this. We built this about 6 years ago at the Media Lab. And now we're looking at more sophisticated solutions. This now integrates a dining table with a bed and a bench, and that just disappears. Now, everybody wants a walk-in closet, right? But that just wastes a huge amount of space. So now this is a just-in-time walk-in closet. And micro kitchens, we're now building a version of this in my lab. So how can you get all of the functionality and the small appliances in your wine cellar and aeroponic food production, everything right in front of you in a very compact space. And it's simple, fairly simple technology, but and fairly inexpensive. It's just a matter of putting together the supply chain and the production, et cetera. Now we're looking at using cross-laminated timber panels built from wood grown and sustainably harvested for us to create, again, these compact spaces, 1 bay, 2 bay, 3 bay, 4 bay. Just take the 1 bay. The small apartments are a lot harder to design. Any good architect can design a big apartment. And in this case, now you have a big king-size bed and a socialization space, guest space, walk-in closet, dining room for 6, et cetera. So we're looking at, in this case, the bed drops down from the ceiling, and so the walls move, et cetera. So we're having a lot of fun with this. And then you can integrate all kinds of technology, health monitoring, sensing, self-cleaning materials, et cetera, all done in a very affordable way since you have economies of scale and you're producing this in a factory. This is a 17 by 17 foot apartment, 289 square feet. So you have a big living room, now you have a big bedroom, now you have a workspace. So we decided to commercialize this. We spun off a company, and now we're building versions of this. This is our test apartment downtown. We've had over 200 people stay there. So she wakes up, hits a button, or uses her phone or voice activation, says, Alexa, put the bed away. The bed goes away. She has separate living and sleeping space at night. During the daytime, the bedroom disappears. Now, in this case, this young woman, sorry, I forgot to turn off the music. You'll have to live with the music. She wakes up in the morning, and she's fixing coffee. And this is a real prototype that we built. This is going to be a product soon. And the bed just disappears, and now she has a living space. So those are the kind of things we're working on. No reason why you can't do this in an office. So in this case, we had, this was a quick hack in my lab, but we have little robotic platforms that we put on all the furniture, and it could do all kinds of things. So brings the printer over to you, or the video conferencing. She sneezes, and now the Kleenex comes to her. You know, she's been sitting too long, sedentary alert. It rises up, takes her over to a treadmill so she can get exercise. You know, some of this was a little silly, but we're actually working on products now for the office. So, you know, rather than we have this notion that urban space is too valuable to be static. You know, it needs to be dynamic and multi-purpose. This is our little nap pod. So you can see this over in our lab now, in our lab. So the guy outside the glass was annoying him. So he dials in the transparency. He's been sitting too long. He dials up the desk, single interface for everything. And he's working standing up. Now he wants to take a nap in the afternoon. He reserved this in the office for a couple of hours. He dials down the bed, and now he takes a nap. Again, now in this we can integrate all kinds of new technologies. Each of these panels are removable and hackable with power and data connections. Financing without banks. This is one of my favorite ones. And we're just starting this project, but just assume that apartment was $500,000. So what if you only had to pay 51% of it and there was a market where investors could buy 49%? You still own it, control it, et cetera. So then when you sell it, you get 51% of the appreciation. You can actually take that to a building scale, tokenize the financing, so you have both the different governance models for the homeowner and for the investors that invest in it. And then there's no reason why there can't be a whole network of properties where you take your token, your equity from one property to the other, so you don't have to sell it. It's a combination between, I think, the best features of rental with the best features of ownership. Gives you a liquid asset, but also you benefit from control and appreciation, et cetera. Order without planning, without planners. This is another one of my favorite one. I think urban planning is complete. I've come from this world, but urban planning is completely dysfunctional, and we need to get beyond that. So here we're moving our little Lego optically tagged pieces for a city. These are Barcelona blocks. If you've been to Barcelona, the new Cerdà plan, new 19th century plan area of Barcelona. And in this case, we're moving our affordable housing microunits from the inexpensive part of the city down to the center of the city where everybody wants to live. And millennials are represented by blue dots, mid-career yellow, senior executive types in red, et cetera. So you can get real-time feedback. So we started doing this modeling process by using Lego units as data units. And we would build these models of cities that were color-coded, where blue is water, yellow was retail, white was housing, black was office, et cetera. But there was no way to evaluate these. It was a great design tool, but no way to really evaluate them. So we started to take it a little farther, first in our own backyard here in Cambridge. This is Kendall Square, and so this is a Lego model where we're modeling wind flow, land use, where is the money flowing. So the yellow highlighted area there is the Cambridge Innovation Center right near here, where there are over 600 startups. MIT is completely dark. You know why? It's a nonprofit. Yeah, there's no venture money. Geolocated tweets, so where particularly are young people active? So 3rd Street is active, Media Lab. Media Lab is that bright building up top. The Sloan School across the street here is fairly dark. And so we've, on that day, I don't know. And then, so now what we've put together is this platform where we have visualizations projected on the table, these optically tagged pieces that you move, a tangible interface, a radar plot that shows urban performance, key performance indicators like safety, security, innovation potential, an agent-based simulation of movement of people, and a 3D view. The radar plot here is key. You see density, there's different types of density. Residential employment. Third places are cafes, restaurants, day and night. Then you map the same thing to diversity. So for example, Kendall Square, where we are now, is the blue line. So you see high density employment, high density, high diversity employment, low density residential, extremely low diversity residential. Only rich people live here. There are just a handful of apartments. Harvard Square in red is a little better, but it doesn't have all the employment. You see, so this is kind of a fingerprint of the social and economic and cultural performance of the neighborhood. So what we do now is we build these tools where as you go through these different scenarios of land use, density, putting housing here and there, different systems, that radar plot updates in real time. And so you get real-time feedback. So for example, here, we're putting RL, that's residential luxury. These are expensive apartments for rich people down. You see the red dots populated on the table. So you see where that people with that profile will be living. Or here we're mapping our 300 square foot micro units to a Lego brick. So there are 12 micro units per floor. Change the densities and everything updates. Or connecting this conceptual world to a perceptual world, flying a virtual drone over the physical model and seeing in real time the rendered view of the city, which could be hyper-realistic images of the buildings. Okay, we've used this in a few places, so I think it's always good to show real-world context. So we started helping, we have a cooperation agreement with Hamburg, Germany, among 9 cities around the world. And in this case, we started helping them model the 2024 Olympics, which you see on the rendering in back of the mayor's head. And then they got hit with the refugee crisis. They were looking at as many as 80,000 refugees coming into the city. And the mayor lost the referendum. He said to us, can we switch and help us solve the refugee problem? So I said, what's the problem? And he said, we know how to build the housing. The problem is working with the communities to identify sites in their communities to build the housing. And this is the typical process when these issues are very political and controversial. So what we did is built 2 tables. We did 44 workshops with 30 people in the community. The mayor had 3 criteria: no ghettos, even assimilation of the refugees, all districts, rich and poor, share equally, and this had to be a bottom-up process where the communities decided. So they would gather around, they would look at these color-coded maps showing suitability for housing. They'd place this piece down that a computer vision system could recognize. That's a zoom window into the second table. They move these Lego bricks around like we were showing, and as they do that, they can see access to schools, jobs, mass transit, shopping, et cetera. They go back and then look how they're doing compared to other districts. You see the 7 districts up there. So it became this healthy competition to see who could accommodate the most refugees. It worked beautifully, and it's now being seen as a model for engaging with communities, this community bottom-up design process. This was an article in the Atlantic. Germany's radical pro-refugee urban planning experiment. It wasn't really urban planning. It was really about a new form of community decision-making, taking full advantage of these powerful simulation recommendation design engines. Boston, another project that we did there. So there was a proposal to put in 4 new Boston bus rapid transit systems, of which you have a lot in Latin America. I don't know. Do you have one in Santiago? Yeah. This is Bogota. You know, the essence are dedicated lanes with buses that operate more like subway stations with a turnstile and are on grade. So we built 3 of these tables. And here, at the regional scale, she locates where she lives and works and how her commuting time would change. So these were workshops we did in the community. This actually didn't work very well, this touch screen. It was a great interface, very powerful, but it wasn't intuitive. The second was at the community scale. And here they could move the Lego bricks around different stations and everything would update. They loved this. People would just play with it. And then the third was the station scale. So here are stations on the side. You move the station to the center. That's the gold standard. And all the data updates as you go this bike lane versus parallel parking. A project we just did in Hangzhou. It's a new 5 square kilometer central business district. This is the scanning technology. Here he's reprogramming the different elements of the city dynamically. And the goal here is to make this so accessible that even a mayor can come in and make decisions. And we're now in conversation with Shenzhen, and they want to do exactly that. They want to have a model like this for public exhibition, but then have the mayor come in and do design work. And here, this is flying the same virtual drone over the model. Economy without currency. So we're also looking at taking this radar plot and identifying the strengths and weaknesses of the community. And the idea is to have a geofenced area with a local token economy where the value of your tokens go up and down according to how pro-social your behaviors are. So if you don't own a car, the value goes up. If you live near where you work, if you shop locally, et cetera, if you volunteer. So there's no end to how you could do these mappings. And then over time, this radar plot can change. We're also looking at the same thing to encourage developers, real estate owners, to make pro-social decisions. So dynamic incentives, dynamic zoning ordinances. So developers get more incentives to build out things that the community needs rather than just simply, in a simplistic way, optimizing return on investment. Okay, new project we're just starting in Latin America, slums without infrastructure. That's slums without conventional infrastructure. And by 2050, it's anticipated that 3.5 billion people will live in communities without infrastructure. These are slums, extreme poverty, informal settlements without land ownership and services. And the cost of bringing conventional infrastructure to these communities is estimated to exceed the annual combined GDP of the US, China, and Europe, which is another way of saying it will never happen. So we're looking at decentralized autonomous systems. So I'm having fun with this without framing, okay? So this is sanitation without sewers. Well, there's a lot of good work going on. This is a community scale sewage processor that can serve several hundred communities. This was funded by the Gates Foundation. But even more interesting is when it's distributed to the scale of a toilet. So this is a toilet that evaporates the waste and packages it into little pellets that are disposed of automatically. Power without grids. Of course, there's a lot of solar, renewable, but this is already, I think, the old way of doing things. I think there's lots of new things coming on. There's all kinds of incredible new photovoltaic technologies that can increase the efficiency. Some say to as much as 90%. We'll see. This is a new project here at MIT. Fairly new. It's about a microfusion reactor that can serve the scale of a community. And the idea is that some are saying is in as short as 10 years, they'll have a prototype. They can just lift this package into a community, fits on the back of a truck, and just provides clean power. Very exciting. Water without pipes. This is a product out there now with solar collectors that collects and purifies the water automatically. Little electrochemical water purifying technology that's out there, all kinds of things. These are just a few examples. We have a whole database of these things we're collecting. These are just a few of my favorite. Communication without carriers. Okay, all kinds of distributed systems. 5G will enable a lot of this if it's deployed properly. Food without soil. We've done a lot about this in my group. This is the MIT City Farm that we had on the 5th floor of the Media Lab for a while. And it's all aeroponics. Everybody know what aeroponics is? Kind of the next step beyond hydroponics. Aeroponics is where you have a chamber where you'll see it here. She lifts this up. And those are the roots. So the roots are exposed and you just have a doser and you mist nutrients and water onto the roots, and you can have all kinds of fancy algorithms to stress the plant to increase flavors, et cetera. So it's making all this more computational. We spun that off to a separate initiative called Open Ag, and this is a food computer that one can now build. This is all open source, and there are schools all over the world now building these food computers. 3D printed food, this doesn't look very appealing to me, but it could be the future. So we'll see where all this goes. So we're going to do a master class in the fall that I'm going to be doing with Nicholas Negroponte, the founder of the Media Lab, and Norman Foster, one of the great architects who's living today. Norman, if you know his work, I mean, he's kind of reinvented airports and did the Bloomberg headquarters in London and the Apple headquarters that looks like a spaceship that just landed. He's very interested in this work, and we'll see where this goes. And every year we do a city science summit. So we have partner cities around the world. We're now Hamburg, Helsinki, Andorra, Toronto, Shanghai, Taipei, Guadalajara, our first in Latin America. Quito will be our second. We hope to sign that soon. We get together every year. So our third City Science Summit will be October 1st in Hamburg. You're all invited. We're doing that in the new Philharmonic. So Satan, we'll send out some information on that. So I have 1 minute and 31 seconds left, so I'd be happy to take any questions if anybody has any. Yes, sir.
First, a comment. This looks like modern times of Charlie Chaplin.
Okay.
Chaplin's modern time, right? New version. That's a comment. No,
Okay. I don't know if that's a compliment or a criticism, but that's okay. I love Charlie Chaplin, so I take it.
I'm sure.
Okay.
But my question is, in this 30 square feet house,
Yeah.
I thought only one or two people living. But how happen when you, like me, have, not now they're big one, but you have 3 children
Okay.
at home. I think it will work.
Well, no. If you remember, I went very quickly, but I showed the 1 bay, 2 bay, 3 bay, 4 bay. You can have 5 bay. You can gang these together, you see, and you can form a whole array. So I didn't have time to show it. But we actually have one solution where you have a big living room. It's like, you guys use meters, right? Yeah. So this would be about a 10 meter by 8 meter living room. Pretty big, right? Yeah. And then during the day, at night, that space gets subdivided, the beds come down from the ceiling, the walls come out, and you have 4 bedrooms. So, or whatever combination you want.
No, but I'm not thinking about
well, and also the same thing, yeah, but then you can, well, sure, but then of course you can transform a 1 bay to a 2 bay and a 3 bay. I mean, you have ownership access issues. I mean, you'd have to negotiate with a neighbor. Well, but if we could combine that with the financing model, these, people can relocate, take their equity with them from a smaller space to a bigger space, you see. And I mean, we haven't worked it all out yet. So there's a lot of complexity there, but that's the idea. So the idea would be as you grow, the system accommodates larger families. And you don't have to sell your old space and buy a new space. You take your equity from the smaller to the bigger progressively. Yes?
With this approach, you are kind of challenging the incumbent industry.
Yes.
And so how is the strategy to rise or to bring the capital to put this in practice?
Well, I think some of these things already have huge amounts of financing, like the fusion reactor. I mean, that's a big deal. MIT's involved, and there's lots of funders. Some of these others are best done by little startups that can be much more agile. The startup that we're doing, the housing startup, we got seed funding here locally, and then we raised our Series A funding from Kozla, who's one of the big Silicon Valley VCs. And then we'll grow the company, like hopefully, getting Series B and C. So, and the third thing we do is we have 80 major sponsors at the Media Lab. So the vehicle, the little 3-wheeler, there's interest in 3 companies in commercializing that at the Media Lab. So we're negotiating with them. So you can do startups, you can, work with big companies, or it can be a big industrial consortium like the Fusion project. Yes.
Do you have a market for those apartments?
Oh yeah.
Have you tested it?
Yes. Oh yeah, no, we're selling. Yeah, we're selling. We're focused on micro units for young professionals right now, but there's also a market for professional dorms, for university dorms, assisted living for elderly people, extended stay hotel rooms. We had Virgin Cruise come to talk to us about reinventing the cruise ship cabin. We've had big manufacturers, big furniture companies that want to come out with a robotics furniture line. This is all just emerging, we'll see, but I'm hoping that we're just on the uptake of this hockey stick that will transform the industry. But one never knows. Yeah.
All right, everybody. Unfortunately, that was all the time we had, and we can't take any questions. So let's give a big round of applause.
Thank you.